Chapter 6 Lines and Angles. You have already studied that a minimum of 2 points are required to draw a line. In this chapter, you will study the properties of the angles formed when two lines intersect each other and the properties of the angles formed when a line intersects two or more parallel lines at distinct points. In science, you study the properties of light by drawing the ray diagrams. For example, to study the refraction of light when traveling from one medium to other, also reflection of light, we need to use properties of lines and their angles. To find the height of a tower or to find the distance of ship from lighthouse, one needs to know the angle formed between the horizontal and the line of sight. Recall that number 1. A part or portion of a line with two endpoints is called a line segment. Number 2. A part of line with one endpoint is called a ray. Number 3. If 3 or more points lie on the same line, they are called collinear points. Otherwise, non-collinear points. Now, recall that an angle is formed when two rays originate from the same endpoint. The rays making an angle are called the arms and the endpoint is called vertex of the angle. You have studied different types of angles such as acute angle, where the angle x is greater than 0 degrees and less than 90 degrees. Right angle, where y is equal to 90 degrees. Obtuse angle, where z is greater than 90 degrees and less than 180 degrees. Straight angle, where s is equal to 180 degrees. Reflex angle, where t is greater than 180 degrees and less than 360 degrees. Further, two angles whose sum is 90 degrees are called complementary angles. Therefore, angle ABC and angle DEF are complementary angles. And two angles whose sum is 180 degrees are called supplementary angles. Therefore, angle PQR and angle STU are supplementary angles. Also, angle ABD and angle DBC are adjacent angles. Here, angle ABD and angle DBC are called linear pair of angles. If two lines AB and CD intersect each other, then angle AOD and angle COB and angle AOC and angle DOB are vertically opposite angles. Draw two different lines PQ and RS. It can be drawn in two different ways as shown. In figure 1, lines are intersecting lines. And in figure 2, lines are parallel lines. That is, the perpendicular distance between the two parallel lines is always same. Pair of angles. Axiom 1. If a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees. Axiom 2. If the sum of two adjacent angles is 180 degrees, then the non-common arms of the angles form a line. The above two axioms together is called the linear pair axiom. Theorem. If two lines intersect each other, then the vertically opposite angles are equal. Given two lines intersect each other. To prove, angle AOC is equal to angle BOD and angle AOD is equal to angle BOC. Proof. Let line AB and CD intersect each other at a point O. They lead to two pairs of vertically opposite angles. Now, ray OA stands on line CD. Therefore, angle AOC plus angle AOD is equal to 180 degrees. And angle AOD plus angle BOD is equal to 180 degrees. Linear pair axiom. From 1 and 2, we can write angle AOC plus angle AOD is equal to angle AOD plus angle BOD. Therefore, angle AOC is equal to angle BOD. Similarly, it can be proved that angle AOD is equal to angle BOC. Thus, two vertically opposite angles formed due to intersection of two lines are equal. Corresponding angles axiom. Axiom 1. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. Axiom 2. If a transversal intersects two lines such that a pair of corresponding angle is equal, then the two lines are parallel to each other. From these two axioms, the result can be stated as theorem. Theorem. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. Given transversal PS intersects parallel lines AB and CD at points Q and R respectively. To prove angle BQR is equal to angle QRC. Prove angle BQR is equal to angle PQA since they are vertically opposite angles. Angle PQA is equal to angle QRC, pair of corresponding angles. From 1 and 2, angle BQR is equal to angle QRC. Similarly, we can prove that angle AQR is equal to angle QRD. Thus, if a transversal intersects two parallel lines, each pair of interior alternate angles is equal. Conversely, theorem. If a transversal intersects two lines such that pair of alternate interior angles is equal, then the two lines are parallel. Theorem. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of transversal is supplementary. Converse. Theorem. If a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Lines parallel to the same line. Theorem. Lines which are parallel to the same line are parallel to each other. Given line M is parallel to line L and line N is parallel to line L. To prove line M is parallel to line N. Proof. Let us draw a line T transversal for the lines L, M and N. Now, since line L is parallel to line M, therefore, angle 1 is equal to angle 2, corresponding angles axiom. Also, line L is parallel to line N, therefore, angle 1 is equal to angle 3, corresponding angle axiom. From 1 and 2, we get angle 2 is equal to angle 3. But angle 2 and angle 3 are corresponding angles and they are equal. Therefore, line M is parallel to line N, converse of corresponding angle axiom.